All right, we're here to talk about some circles. This vocabulary we've already talked about, but just a quick review, right? Our radius goes from the center, right? The center is just a point in the middle. The radius goes from the center to the edge of the circle. If the radius goes all the way through, right, because this is actually the radius right here as well, but if the radius goes all the way through and we have two radii connecting to form a straight line, then we call that a diameter. And a diameter is actually a type of chord, right? A chord is a segment that goes from one edge of the circle to the other. It's just if the chord goes through the center, we give it a more specific name, diameter. The two lines that go through the circle or touch the circle, we've got the secant, right? So the secant is a line, it goes forever. For me, the easiest way to remember the difference between a chord and a secant is the secant keeps going. It keeps seeking something, right? It's looking, it's seeking, it's going. So the secant seeks, keeps going. And then we have this other line that only touches the circle in one point. The point where it touches is called the point of tangency, different than the tangent we've been doing with trig. But it's called the point of tangency because we call this line a tangent line. All right, on to some new stuff. So we're going to start looking at the measures of the angles and the arcs in the circle. And so this first one, we need to make sure we're okay with the way that this is written, right? The symbols. So M just stands for measure, right? And when we're talking about the measure of an angle, and now when we're talking about the measure of an arc, right, which is the part of a circle, we're going to always measure both of those in degrees. Later you'll learn about radians, but we're doing degrees. And then if we give three letters, we know that the middle letter is the actual vertex of the angle. So angle BAC means we start at B, go to A, end at C. So I can look at this. Boom, it's right there. The measure of that angle is 60 degrees. Well, what we're going to learn today is that when we find the measure of an arc, the arc will always be the same measure as the angle that formed it. So this angle right here touches point B, touches point C. So this arc that is in between, which is called the intercepted arc, we'll talk more about that, but the intercepted arc will always be the same as the central angle. So if the central angle is 60, that means the intercepted arc is also 60 degrees. Okay. If we list the arc with two letters, that means we are going the shortest distance between those two letters. So the shortest way for me to get from point B to point C is to just go right there, right? Nice and quick. But if I wanted to go a longer way, to go from B to C, I could go the other way around, right? That's a much longer path. And we call that longer path a major arc. So this intercepted arc right here is actually called a minor arc because it's small, right? It's less than half a circle. But if we go the long way around, right? If I go from B to C and I go all the way around, that is called a major arc. And we will use three letters to name a major arc. So we have the point that we started with, right? Point B. The point that we ended with, point C. But then in the middle, we put one more letter to show that when we went from B to C, we went through point D. So if I'm going to go from B to C, but still go through point D, I need to go this longer way around. So that's called a major arc. Well, how many degrees are in a circle? 360 degrees, right? So if this minor arc is 60 degrees, how can I find the major arc? Right? That's just the rest of the circle. So I can take the 360 degrees in a circle, subtract the 60 degrees that were in the minor arc, and I get that the measure of the major arc will be 300 degrees. So this arc here, 300 degrees. All right. The length of AB right? This is a segment. Well, first off, AB, what do we call that segment that goes from A to B? It's a radius, right? And so this particular radius is 5 centimeters. And then if we look at AC, is AC also a radius? Yeah, right? It goes from the center of the circle to the edge. And every radius of every circle, well, every radius within the same circle will always be the same length. So if this radius is 5 centimeters, it means that this radius would also be 5 centimeters. If I decided to draw another radius, it would be 5 centimeters. 5 centimeters, right? It doesn't matter where I put that radius, it's going to be the same length as all of the others. All right, so key idea. We've got a couple of these. Central angle. Central angle is an angle where the vertex of the angle is the center of the circle, right? That makes sense. Center, central, right? So this is a central angle right here. And then the intercepted arc is the arc that gets intercepted when we take the two sides of the angle. Right, so if I draw those two sides, this part of the arc that gets intercepted by the angle is called an intercepted arc. Intercepted arc. Well, the key fact is the central angle is always equal to the arc, or the intercepted arc. Which, by the way, is this arc here a minor arc or a major arc? Minor arc, yes, because it is less than half a circle. All right, if this happened to be a 120-degree angle, we would then know that the intercepted arc is also 120 degrees, because the central angle and the intercepted arc are always congruent. Okay, the other key vocab that we talked about in this section was minor arc versus major arc. So minor arc is just less than 180 degrees. Major arc is more than 180 degrees. Or sometimes I think about it as the minor arc is the shortest way between 2 points, and the major arc is the longer way between 2 points. What if it's not a minor arc or a major arc? What if it's exactly 180 degrees? We're going to talk about what that's called right now. All right, so this is neither a minor arc nor a major arc because they are the same size, because they are both half a circle. So we just call those semicircles. Semi means half, so it's half of a circle. So we've got minor arc, less than 180, major arc, more than 180, but if it's exactly 180 degrees, that is a semicircle. Okay, let's go back to angles real quick. Angle COB. Okay, if I highlight that angle, I start at C, I go to the vertex, which is O, and I end at B. So my angle is right here. Well, that angle sure looks like a straight line, right? And we talked about lines a lot earlier this year. We talked about linear pairs. But we know that if we draw this arc here, that arc is half a circle, right? And how many degrees are in half a circle? 180 degrees, which we already knew that because we know that a straight line will have 180 degrees. So the measure of the straight line, angle COB, is 180 degrees, which means the arc from C to B, right, the semicircle, would be how many degrees? Nailed it. 180 degrees, which makes sense because it's a semicircle, which is half of a circle, and half of 360 is 180. All right, a little bit more on the radius and diameter. This problem right here, the length of CO, right? CO is a radius. That length is 10 centimeters. Now CB is more than a radius, it's two radii put together to form a diameter, Right? So if the radius is 10 centimeters, how long is the diameter? Yeah, 10 plus 10 is 20 centimeters. All right. Whoa, there are a lot of angles to find on here. But that's okay, because we know that central angles and arcs are the same. We know that a full circle is 360 degrees, and we know that a semicircle is 180 degrees. So we can use that knowledge to help us find these various arcs and angles. All right, first one, arc BF. So first off, arc is the curved part. So I'm going to go to this curved part right here. And I notice that the central angle that forms that arc is 60 degrees, which means this arc is 60 degrees. Very good. Okay, arc CB. CB. I know I'm going the shortest way between the two because it's only 2 letters, right? So it's going to be a minor arc. Well, here's another easy one. That angle is 52, which means the arc is 52 degrees. Arc DC. Well, kind of another easy one because the central angle, right, if we go to the center, the angle that forms that arc is 90 degrees, which means the inscribed arc is also 90 degrees. So again, key idea, central angles and their arcs are congruent. All right, actually I'm gonna write these up here as we go. So that first one was 60, next one was 52, and then we just got 90 degrees. Okay, arc ED. Now I've got to actually calculate something. So I want to find this arc here. Well, usually I know it's the same as the central angle, but I don't have that either, right? So how am I going to do this? Well, what do I know about a semicircle, right? A half a circle has how many degrees? 180 degrees. And I know that in this semicircle here, I already have 52 degrees and 90 degrees. So I just need to find what is left over to make the full 180. Or I can look at the arcs, right? 52 degrees, 90 degrees. We need to make the full 180. So I can take 180 and subtract the 2 that I already have, which if I add those together, that's 142. And if I subtract that, I get 38. So the measure of this arc right here, 38 degrees. All right, arc EF. Why don't you go ahead and find the measure of arc EF? What is the measure of that arc? All right, hopefully you came up with 120 degrees. Right, and this one I would probably do by using the same straight line right here, or the semicircle, right, that created. We know that the semicircle needs to have 180 degrees. We already had 60 degrees, so we could take the 180 that we need, subtract the 60 that we already have, and that leaves us with 120 degrees. Okay, the next one, I've got to be careful. It says arc FEC. You know, I need another color. Let's see what I can find here. Let's go with orange. All right, so arc FEC, now it's 3 letters. So that means I'm going to start at F, but I have to go towards E. So I'm going to go towards E, and then I'm going to end at C. So I'm going to keep going around. Right? Arcs are around the outside, don't cut into the middle. Arcs go around the outside of the circle. Well, how can I find the measure of that big arc, right? Or of that major arc? You could do it a couple of ways. One way would be just add the pieces together. Right? We've got 120, we've got 38, we've got 90. So if we add 90 plus 38 plus 120, that should be 248 degrees. Now you could also take away the pieces that you don't have in that arc, right? So we could start with 360 degrees. We could subtract 60, which gets us down to 300, and then subtract 52, which would get us to 248. All right, so again, we have some problems that have multiple ways to approach them, which I like. All right, angle EAD. EAD, that's this angle here. All right, we know that central angles and arcs are the same, so that one's going to be 38 degrees. Angle EAF, well, we found that that arc was 120, so the central angle is 120. Angle DAF. All right, this is getting kind of messy here. Hopefully you can still figure out where we're going here, but DAF, right, this angle here. This goes back to angle addition that we did the first week of school. I know that this angle or arc were 38 degrees, and this one was 120. So if I need the whole thing, I'm just going to add those two pieces together. So I get 120 plus 38, 158 degrees. And then finally, the last one, angle BAE. So start at B, go to A, end at E. Well, that's just my diameter, right? That's a straight line, and the number of degrees in a straight line, we know, is 180 degrees. All right, that was a lot on one slide. But it's all pretty straightforward, right? Central angles and arcs are the same. Semicircle is 180 degrees. Full circle is 360. All right. If we take a look at this one, angle ACR. So ACR, that's this angle right here. Well, that box tells us that that angle is 90 degrees. Okay, and if that central angle, right, central, if that central angle is 90 degrees, then the arc that it forms, right, this intercepted arc, which happens to be a minor arc, would be how many degrees? Right? It's just going to be congruent. It will be 90 degrees. But if we take this same intercepted arc, right, we have A, we have R. If we now go to an angle that's not in the center, but is rather on the edge of the circle, we're going to get a different measure. Right? That is definitely not a right angle. It's not 90 degrees. So this angle here, is it going to be, well, let me ask you this way. Is that angle acute or obtuse? Right, that's an acute angle. So I know that it has to be less than 90 degrees. So some people try to say that this is a bigger angle because the sides are longer. Right? The length of the sides has nothing to do with the measure of the angle. This angle is acute. It's small. It's less than 90. So I'd ask you to take a guess, but I don't want you to get a question wrong on a guess. So I'll just tell you. The measure of this angle here is going to be 45 degrees. Well, how is 45 related to 90? It's half, right? So if we know an arc, right, we knew this arc was 90 degrees. We know the central angle will be the same, right? 90, 90. But if we go all the way to the edge of the circle, that angle that gets formed will be half of the arc. All right. So again, if we have this angle here, it will be half of angle B, or half of the arc. Right? If this angle is 80 degrees, that means the arc is 80 degrees, but angle A is only half of that. Right? So half of 80 would be 40 degrees. All right, let's give these some names. All right, central angle. We already gave that name earlier. All right, central angle means it's an angle at the very center of the circle. Intercepted arc. We've talked about this arc that gets intercepted by the angle, right? So it's the part of the circle that's in between the sides of the angle. But now we've got this new angle down here, right? More vocabulary. That is called an inscribed angle. So central angle is at the center. Inscribed angle is at the inner edge of the circle. And what do we know about the inscribed angle compared to the central angle? It is half the measure. So I know that angle AOB was 106 degrees. I know that arc AB, right, is the same. But angle ACB, right, angle ACB is not going to be the same. How many degrees will that be? Yes, it will be half of 106, so it will be 53 degrees. All right, so again, this key vocabulary, we're gonna use it a lot. Central angle. Well, what's the name of the central angle in this? Which angle is my central angle? I know my central angle is angle CPB. All right, start at C, P is the vertex, B is the other end. Or we could go backwards and call it BPC. But the key point is the vertex of the angle is P, all right, so that goes in the middle. And based on this diagram, the measure of that angle is 70 degrees. Okay, the inscribed angle is the angle that is on this inner edge right here. All right, so that's angle CAB. All right, we can ignore the P because that's not the vertex, but C to A to B. So angle CAB, or we could call it angle BAC. All right, we can go backwards. If the central angle is 70 degrees, how many degrees is the inscribed angle? It's half, so it will be 35 degrees. Now we could also work backwards, right? If we knew that this angle was 35, to find the central angle, we could just double it, because we know that it would take two of them to make one central angle. All right, and then finally our intercepted arc is this arc right here, which is arc CB, or we could call it BC. But we also, on top of arcs, we put a little arc. Right, so a nice little curve on top as a symbol to show that we're talking about an arc. All right, we're almost done. Another example, done quite a few of these. Angle COB, all right, is 98 degrees. Angle CAB will then be half, right? So 49 degrees. Hey, go 49ers. Arc CB is this arc right here. If the central angle is 98 and the inscribed angle is 49 degrees, what is the measure of our intercepted arc? That's right, it's the same as the central angle, so it is 98 degrees. And then the measure of arc CAB is going to be our major arc. All right, go ahead and find the measure of that major arc. Good job, you guys are so smart. All right, we know that there's 360 total degrees in a circle. The minor arc made up 98 of those degrees. All right, so we can subtract 98, which gives us 262 degrees left over. So the major arc is the other 262 degrees. Okay, what if the inscribed angle is a right angle? Well, if this angle is 90 degrees, and that's half of the central angle, right? If this angle is 90 degrees, how many degrees is the central angle? Of course, it's 180 degrees, which I can also tell because it's a straight line. All right, so angle ACB, that straight line, is 180 degrees. Arc AB is then going to be the same as the central angle. Right? And again, it's not really a minor arc or a major arc, it's just a semicircle because it's half of the circle. And then angle AIB, well, I already got the box there, I already put the 90 there, but I could also use the fact that the inscribed angle will be half of the arc or half of the central angle. So half of 180 is 90 degrees. So anytime you see a right angle as the inscribed angle, we know that the arc that it forms will be 180 degrees. Or we also know that if we have a diameter, if we were to draw an angle that goes to each end of the diameter, this has to be 90 degrees, right angle. All right, yep, last problem. Okay, oh man, this looks tough. There's 3 different angles. There's all this going on. Oh no. All right, angle ACB. Well, I'm just going to measure that with my protractor real quick. All right, my imaginary protractor tells me that this angle is 60 degrees. That may or may not be accurate for the sake of what we're doing. It's 60 degrees. Okay. So if that angle is 60 degrees, what's the measure of arc AB? Well, if I extend these sides, they intercept arc AB. And will the inscribed angle be the same measure as the arc? No, right? The central angle is the same as the arc. The inscribed angle will be half of the arc. So if this is 60 degrees, 60 is half of 120. So that is 120 degrees. And then if we take a look at our other 2 angles, what I notice is that they also go to points A and B, which means they have the same arc. So if they also have an arc of 120 degrees, and they're inscribed angles, they've got to be half of that. So this angle is 60 degrees. And what's this angle? Yes, that is also 60 degrees. So anytime you have inscribed angles sharing the same arc, right? If I extend these sides, they go through A and B, so the arc is still 120. If they share the same arc, they will have the same measure, which is half of the arc. The triangle says you're pointless. Get it? No points. But the circle says, that's how I roll, right? There's no points to prevent him from rolling. He can roll. All right. See you later, Titans.